Klaus, the floor is yours.
Okay, thank you. Thank you for having the chance and the pleasure to be the last speaker of the day when everybody is a bit tired, so I will do my best to be interesting and introduce to you where we stand with the NEO, because the NEO has quite a history behind itself, and you will see where we stand. I will touch on the development. I will largely focus on this program on quality and maturity, and I will tell you where we are in terms of program progress, and for sure you will see some pictures of real hardware, because the NEO is real, it's not PowerPoint anymore. So, you know this picture, it's about 2 years old, so why do I show it again? Because it's still the same, which is the good news. We have said the NEO will be a minimum change with maximum effect, and we only want to go out and change the engines, and for sure we will have to do some extra work. We need new nacelles, we need a new pylon, but we don't want to go out and make further changes. Why so? Because we want to keep the product as it is. We want to go a low risk, we want to have high maturity, and we don't want to force the airlines into big investments regarding spare parts. So we have a target to have a high commonality between the NEO and the current engine. Also, we don't want to force the airlines to go into trainings with the pilots, so we want just to make a minor training program if you go to the NEO, and we simply want to keep it simple. We knew our platform was good enough and was allowing to integrate the largest engines in this market segment, and we knew with this we would fulfill our requirements. Now 2 years later I can tell you, yes, we are going to fulfill the requirements, especially the fuel burn and the range, a couple of others, and the picture is still the same. We did not need to go out and make further changes, which in the end would have counteracted our targets. So the NEO is still a minimum change with a maximum benefit. But it does not mean, as it's just a minimum change, we take it easy. We are not going out and say, okay, let's start this little engine integration, we don't need to make a big fuss out of it. We have said, no, what we are going to do for development of the NEO will be exactly at the standard of the A350. So the product development plan, which you see here in very rough terms, but I'm coming back to it later on, is deterministic. We have clearly broken it into milestones or maturity gates, and we have just passed NG7, Fabrice has said it a couple of minutes ago, closing off the detailed design, but this is for sure broken down into many, many piece parts. Our schedule for the moment includes more than 30,000 sub-milestones, so all the activities are really broken down. And when we go out for such a maturity gate, it's a cascade of many reviews where we are really reviewing thousands of deliverables, and we only get a go in case we have really delivered what we need to deliver. I can tell you for the NG7, which we have passed a month ago, we had not a single discrepancy. It means we are really on the target. We have set ourselves 2.5 years ago, and we are exactly on this line. Something came in new, but we are introducing it at the very end of the NEO journey, and it will be exclusive to the NEO. Thomas just introduced it, is the Airbus Cabin Flex. You may know about this change, which is basically the introduction of an overwing exit, and this is forcing us to move the door number 3 a bit backwards, because we need to get space for the evacuation slides in case of. That's the only reason. But what is unique on this aircraft, and for sure with the 5th door you get higher evacuation limits, so we can go from 220 max pax to 236. In terms of evacuation, we could even go further, but it doesn't make sense because then you are sitting too compressed. This gives us about 5% seat fuel burn efficiency. And here we can see it's basically 2 things making up the efficiency. You reduce your fuel burn, which we are doing with the engines, and then you get more seats in. More seats not only if we go to high density configurations, also we wanted to give the airlines, and I think this is unique in the industry, a high level of flexibility. Because what you do today is you have your grid of floor space, and you have the interruptions with the doors where you need to keep this cross aisle free of seats. And then you are somehow trying to put your seats in between. And if you have a certain ambition with a certain business class and economy class, for sure you are always ending in front of certain walls which are made up by these seats, especially in the front of the fuselage, where you host the business class. That's why we have said, okay, with this fifth door, which primarily for sure gives you the capability to evacuate more people, hence to get more seats into it, we can also make use of it, and we can deactivate the door number 2, which in certain cases today stands in the way of your layout and forces you to arrange the seats in a way you don't want to. And that's why it's called cabin flex, because you can choose between all kinds of configurations. For sure, when you take delivery, you are just taking one, so you can take 4 doors, you can take 5 doors, you can take a deactivated door, and even later on in service, when you want to change it, you can do it very easily. Now, the change of the door arrangement afterwards takes less time than the reconfiguration of the seats. So we are extremely flexible. We have not only increased the seat capacity, we are then increasing also the seat capacity when you are not using the maximum capacity, because you are not using seats as a matter of constraint in your layout. Also an indication that we are further on developing this aircraft, the NEO, is that there will be no weight hit. Yeah, we will introduce weight measures for sure with the fifth door and the fifth door frame. You can imagine you have some weight to invest, but we have found our ways to minimize it down to 0. So the aircraft will have the same manufacturing empty weight. And the current one means when you have the ISO layout compared to today, you can fly the same distances and you have no disadvantage from this introduction. The next one, quality and maturity. You may say, wow, this is boring. But I can tell you it's not boring. It's maybe the most interesting on this program, besides these nice new engines, because for sure our customers who are not getting an all-new single-aisle aircraft, they get the minimum change, they have certain expectations. The expectation number 1 is for sure meet your performance targets, means the fuel burn. But the next expectation is we don't want to see this introduction basically. Yeah? We want to fly the NEO like we have flown the CEO. We want the same operational reliability, and basically it's just another aircraft in our fleet of CEO aircraft. So that being said, we have started right from the beginning of the program and said we need to invest a lot in quality and maturity. And we need to do it in a way that it has never been done in the industry. And for sure, we were looking out where we could go and learn something. And yes, we can learn from ourselves. Secondly, we can learn from the automotive industry. And I will show you a couple of examples how we took lessons learned, first of all, from ourselves, but then also from the automotive industry. APQP is an automotive standard. Some car companies, and maybe mainly in the North American industry, you will really find this term. If you go to European or Japanese car industry, you will find similar terms, but what is behind is always the same. It's a suite of tools which enables you from very early, when you are setting up your requirements, when you are formulating what you want to achieve with your product, down to the development and industrialization phase, up to delivery and even ramp up, is a tool set which makes you ask certain questions all along the chain. In fact, it's a suite of 29 elements, and we have decided to deploy it on the NEO, and we are doing this now since the beginning of the program with clearly one target, right first time. Right first time in development means we are sure to meet our entry into service, but also we are sure afterwards not to encounter any problems. Some of the elements, I just quote few of them, is, for example, you make so-called DFMEAs, so you make a failure mode effect analysis on your design. You are doing the same later on for production. You make statistical process analysis, and you size your measurement system, like it's been done in the automotive industry, because these guys, they are technically not as complex as we are, for sure. An aircraft is another thing, like a car. But we always see them, they come out with the first product, and they ramp up within 3 months, and then the new car basically is better than the previous generation, and we want to take this benefit also into the aircraft industry. As a large part of the NEO is not made in-house, Its engines and nacelles are bought, and so we can say more than 90% is buy, the rest is make. For sure, it was essential that we're not only doing it for the change perimeter that we do in Airbus ourselves. We also needed to work with our partners, the engine manufacturers and the suppliers, to say this is something we can only do jointly. It doesn't make sense if we do it and you don't do it, it becomes something else. And we have in fact managed to work with Pratt & Whitney, with CFM and with the nacelle suppliers to exactly do the same thing. So it's one integrated approach, because we don't want to be good on one area but fail on another area. We have said we need to be good all over the plane. And that's why we have deployed this not only for our in-house production, we have deployed it for sure also for the engines, for the nacelles, the bleed system, and basically everything which is majorly affected by the NEO. Design maturity. I've said we also learn from ourselves. That's the easiest way to do, but in theory, in practice, sometimes it's very difficult to do it, because you're starting something new, you ignore what your predecessors have done, and you are proud to do it better, but not asking them. And this is clearly something we didn't want to do, because luckily, we have made a couple of new developments over the last decade and the last years, and we are still in the middle of it with the A350. And we have built a database, and this database includes design maturity items. I could cut it short and say problems we encountered. We encountered in the design, in production, or even in service, and those are all fed into a database. We have screened this database, and for sure not all of them would be applicable to the NEO, because it's just a minor engine change, but 2,000, which is about 50% of this database, are applicable. And we have screened them one by one. What do we need to do to avoid this problem? And we have gone through a little bit more than 2,000 of these items, and they are all incorporated in our design now. Or later on, they will be specifically incorporated into our testing. This is a way where we make sure that every problem we have already encountered in the past on A380 or A350, also on Sharklet, is not going to reappear on the NEO. Another one, iron units, that's why we have this nice Gaussian distribution curve. Normally when you go and certify your aircraft, you build a very good aircraft, but you have scatter. Everything has scatter, each and every component, equipment system has a scatter. And what do you do normally if you want to be very convincing and you want to show very good results? You take the best, and you take the one that is just on the nominal level, and you do it for all the neighbor components, and in the end you build the perfect aircraft that you will most probably never ever build again. And this for sure does not show discrepancies, because it's simply too good. But it's too good to be true. That's why we have said we go to the extremes of the Gaussian curves. So we go to the upper limit and the lower limit, and we take components at this limit, and we combine them in a way where we know where they don't like each other. And then we test the beast. And then we see if the result is still good as we have expected. If not so, we would have to take measures like perhaps narrowing the tolerant bands, having higher tolerance, challenges, or even going and changing the design. And this is also something we are going to do first time on the NEO. For sure, with a program running at high rate, you have lots of opportunities, you have more opportunities to do it. It's also a reason that we do it on the real aircraft. It's the reason why we have 8 aircraft flying in flight test. And the flight test program, all in all, of the NEO, even if just a minor change, a minimum change in terms of flight hours, is the same like on the A350. Another one, early testing. We do a lot of front-loading our test program. In fact, the test program on the NEO has started more than a year ago. We use the current aircraft. We test equipment that we need for the NEO already now. We call it early flight test. All the system developments we do on the NEO has been done in a so-called model-based engineering approach. It means we have generated the function of the system as a model, and we have combined these models, and then we have simulated how the whole thing would work together before we have frozen the specifications and send them to the suppliers and say, now this is what you have to program. So we know before that it works. Sorry. Another one you see on this chart, it's even physical. For sure, these new engines have the property to generate very hot exhaust, even more than 200 centigrade higher than the hottest we have for the moment on the A380. And also the core engine, even if the overall aircraft is extremely silent, the core engine can produce quite a nice level of noise. And if you combine the regime of sonic stress and thermal stress, we have something in the vicinity of the engine, mainly in this aft pylon fell, this nice piece of metal that you see, which is exposed to stresses which are beyond belief. So we are aware of it, and we have said, okay, we need to find a new innovative design solution, which we have found. We have screened several possible designs, and then we have said, okay, this is so essential, we need to test it. And where can we test it? The hottest and the loudest beast we have today is the A380. So we have said, then let's build it, and let's build it at the full scale of the A380. And we have made ground test and flight test with this design. The design has behaved even better than we anticipated. And this has been one of the key risks for the integration of an engine into the airframe. And we have managed it, but we are not just building on trust, we are building on test, and we are building on real results. And this is out of sight for us now. Industrial maturity, here is also an innovation. When we talk to the automotive industry, and we did it with Volkswagen, with BMW, with Renault, we in fact worked with many of those suppliers, or automotive suppliers, and we asked them, how do you manage the ramp up? Because the Neo will ramp up very steeply. We never hear, sometimes you hear some trouble, but largely you are introducing a Golf 7, and you see it in the showroom, and 3 months later all your neighbors have it. So obviously they are capable to stand a very steep ramp up. And the answer was very simple. I cut it short. We do it before we need it. Before we really have the cars in the showroom, we have already made the ramp up. We have produced at a full speed, they call it run at rate. We have said, okay, if this is a solution all over the place, we should probably do the same. And the question is, yes, but we cannot produce 500 AC20s like this so-called 0 series or P series like the car guys are doing. We have said, no, we need to have something smarter. We need to tailor it to the needs that we have. And you see this nice curve on the bottom right, which shows the ramp up, in this case, of an inlet one component. And we have said, okay, the takt time is decreasing when you are increasing the output rate in the course of the ramp up. And you see these little needles going down. And we will make this needle going down before we really need the product for delivery. It means we are stressing the industrial system, and we go up to the full rate about 1 year before we really need it in terms of delivering to our customers. And then we can stress test for sure the production facilities, we can stress test our workforce, are they skilled enough, we can check the logistics, and we can check many other things. And if there is something we need to correct, we have a year of time to do it. But we can safeguard the ramp up. And this is going not only on component level, it's for sure, it's on detail part level, component level, goes up to the full aircraft, and it goes up to the full engine. Also on the full engine level, we do exactly the same. Again, our partners and suppliers are doing what we do. It's not one single spot going out for something new, for something very good. It's the whole industrial system doing the same. So where do we stand? Maybe that's the most interesting question of the day. This is a different presentation of this product development plan. And you can see we are at the end of the design with the A320 and A390 because they are almost common, and since about 5 weeks. 5 weeks ago we have officially closed the design, so the books are closed now. There's very, very few elements we are still working on. And for sure the test will tell us to change something and we have to reopen minor things, but it's done. The good thing is that having closed the design, you need to look upstream. What can reopen your design, and what would reopen your design if you have a performance problem? We have no performance problem. We are at least as good as we want to be. So we will not go out and chase weight. We are not going to chase fuel burn. It's done. It's behind us. Secondly, requirements from the authorities. We have signed commitments on all certification plans. Everything is frozen. Nobody will come around the door and say, yes, but for whatever certification reason, I want you to incorporate this and that into your design. No, everything is signed, done deal. No change coming from this. So we can head towards the industrialization. We don't need to fear that for any good or bad reason we have to revisit the design. A321 is at the end of the concept, so it will enter now in the fall into the detailed design phase. A large part of A321 is fully common, especially the new part is fully common with the A320, so there's no difference on the engine, there's no difference on the nacelle, there's also no difference on the pylon. It's exactly the same, means this is already done and accomplished together with the A320. And the last one has just left the concept phase. ACF, I've already told you, it's in its early days, but as I could already tell you, and you can see we are quite advanced, for example, that we are already sure that we will need the same weight like that we have on the current NEO. And for sure, not on this chart is what Tom has introduced you. There's other things to come, e-taxi and things which are reaching out beyond the NEO. And that's anyway the strategy of the program. We are introducing major significant changes to the benefit of the customer. We are not making something all new, but we will not stop it. The NEO is just the beginning. ACF is the next one coming right after, being developed in the same setup, and there's lots of things in the pipe. So it's a hybrid strategy. Keep a high output rate with your deliveries, which is generating the cash, but at the same time go in real incremental steps to improve the product in a way that the customer still has added value in the future. Engines. The gear turbofan is flying since mid of May, the Pratt & Whitney engines. We have 4 engines in test. I think we have accumulated about 400 test hours. Fuel burn is better than predicted, no problem with that, and the test program is running very smoothly. As I've said, we are confident with our performance. We don't have to go back to the design for performance reasons. We know it with the engine. CFM engine assembly is just starting now as I speak. So the first real NEO engine has started the assembly process, and it will also go to test in fall. There have been lots of component tests being made with the engine not at exactly the NEO scale. It was sometimes a little bit smaller, but knowing in engines scaling up is easier than scaling down. So we are quite confident that the overall engine will behave at least as good as the components tests have shown. Last one, the NEO is real. We are 2 years ahead of competition when the MAX is delivered. We have already 400 NEO aircraft flying, so the probability is when you are invited to the rollout ceremony of the MAX that you will fly the NEO aircraft is very high. And the NEO is real. You see components all over the place. It's just some. I get these pictures almost every day. It takes a reasonable part of my time to congratulate the teams and say thank you, but this aircraft is real. We will be in the final assembly line in less than a year, and it will not be 2 years when we will be flying. And in October 2015, we are going to deliver the first aircraft, as we have committed, and I think we are in really, really good shape. Thank you.
Thank you, Klaus. Very convincing. And now we do a joint Q&A with Tom and Klaus on the podium. And Tom with back. Then let's start questions with Edison Schomer. Your front row.
Question in connection with Chartless. What is the status of the lawsuit with Aviation Partners and Airbus?
Maybe I leave it to you.
Yeah, the discussion still goes on. There's no great urgency. We'll work our way through it. We think we're in a very strong position, so we're very relaxed about it.
Achim Figen from Aero magazine.
Just a question regarding the maturity you mentioned. Having parts a year earlier than you really need them puts a lot of financial pressure on the suppliers. Can they cope with this, or do you have to help some suppliers to have parts ready more than a year before they're actually needed for serial production?
Here you're discussing in the frame, sorry, where are you? I don't see the one. Sorry, at the back. You mean in the frame of the NEO ramp-up?
Yes.
Yeah, okay, I'll let Klaus answer first, and then I'm happy to come back in general balance sheets and packages.
Very simple answer, we pay it. We order in advance, and when we order something and the goods come in, we have to pay it. So we are not pushing the burden to the suppliers. It's our business. We will pay it, we will consume it, we will hold some inventory. We are doing it consciously, but we have said it's worth doing it. It's, by the way, not a very impressive figure, because you are burning it off immediately. Also, the parts we are going to pre-produce are exactly of the final configuration, so they will flow into the next aircraft coming along. So in fact, we are not holding inventory for a very long time, but we are not pushing this problem into the supply chain.
Next question to Karen Walker. The silver mic. Can we exchange the mic? The orange mic.
Just speak to Karen.
Is that working? Yes.
Yeah, that's good.
The 236 seat A320, what would be the seat pitch on that?
It will be a very comfortable 28-inch seat pitch. But if you consider the latest seats, for sure it's a horrible figure, but you gain 1 inch of living space from the new slim seats. So I guess every customer who would take this configuration, for sure he would take also the latest seat generation on board, which virtually gives you 29 inch of living space.
Next question to Airline SDE.
Again, a question about the winglets. Maybe not about the NEO, but why did it take Airbus so long to introduce those sharklets? I mean, Boeing is flying them for I don't know how many years on the 737, and also they were introducing quite a radical change for the winglets that they will be putting on the MAX. Are those new winglet features? I mean, going up and down. Would that be an option that you might think about for the NEO as well?
I think, first of all, to your question about why did it take so long, I think when the 737 Classic transitioned to the NG, there was no wingtip device on the old 737. So there was clearly a vortex issue. We always had a wingtip fence on the 320 family, the single aisle family. And that wingtip fence was reckoned to be worth 1.25%, 1.5%. So it was always a more difficult business case, and we were always looking at trying to get a design that would be optimum enough to make the business case really work. And so that, I think, was one of the reasons why we went through this pretty long iteration. I think we've now got a solution, so that's the main thing, and you'll see, in fact, that, as you go around, you'll see a lot of 320s or single aisle being delivered with the sharklets fitted. And in fact, all the aircraft that are being built now have all got sharklet-ready wings, whether the customer takes the sharklet or not. I think to the comments on the MAX, we did look at many different configurations. And we have an up and down wingtip device on the 380, and in fact the old 320 wingtip device was an up and down. It had a blade below the wing surface. But clearly, when you make all of those trade-offs, there's many different factors. And in particular, your concern is, what does it do to wingtip loading? And if I increase wingtip loading, is there enough reserve already in the wing, or do I have to put more structure back in? And if the answer is yes, you do, then the trade-off doesn't work. So I think with the sharklet, we've got the optimum combination of geometry, aerodynamic improvement, and minimizing the amount of structural reinforcement.
Next question to Ben Sandilands.
Question for Tom.
Sorry, Ben.
Hi, Tom, over here in the outer darkness.
Oh my goodness, you're hiding at the back. I see that.
Tom, I come from a very distant place where we have actually a desperate need for a larger A380 by the end of this decade because of the extraordinary constraints on our major airports. But do we have a hope of actually seeing an extended capacity A380 by, let's say, 2020?
I think it's a good question. It's one that we ask ourselves. I think if you were to talk to, say, Tim Clark, he would say there's only one thing wrong with the 380, and that is it's too small, and you need to get on and do the 900, and he said it again very publicly recently. I think for us, the question then would be, if you're going to do such an aeroplane, what would be the business case, and is it only for one or two customers? But we do look at all sorts of other alternatives. I mean, one of the things that John will probably mention tomorrow is that we look at the 11 abreast seating that we can offer. Because today, the 10 abreast seating in economy on the 380 is very comfortable. But the question is, do the airlines really give you any value or any benefit in a competition for that generous layout? And what we can do is take 11 abreast seating with more or less the same seat layout and the same cushion width that you have today on, say, a 777 Air France economy layout at 10 abreast. So the same comfort standard. As John Leahy would say, a very comfortable 11 abreast. I'm not sure, you can ask John tomorrow how many times he's flown in a very comfortable 11 abreast. Someone ask that question for me tomorrow and see his reactions. So it's a very comfortable 11 abreast. The question then is, are the airlines interested in that? Some might be, some not, because some will feel that it perhaps dilutes their brand too much. But then there is other options. You know, I think a lot of the airlines that had the original layouts, I think probably they had a very nice layout at the beginning. They enjoyed it. You know, it was a real kind of blue ribbon of the fleet. I think now you've got more airlines coming back round to look probably in a more hard-nosed way at how many seats do we get on this aeroplane. How do we really want to have that number of first class? Should we have more business class? We'll get a better yield. So I think there's a whole kind of re-evaluation. And then to your question then, would we consider a stretch or doing more? We'd always consider it, but I think today the question would be, what would that mean in terms of business case, and would we launch it? Does it really make financial sense?
Next question to Andrea Rossman.
Andrea, you're not allowed any questions, Andrea. You stopped your foot.
Question. Tim Clark said to us a couple of days ago at IATA that there were delays on the retrofit of the wing for the A380 because you guys were struggling just to deliver the number of planes you needed, regular A380s.
Yeah.
And I'm wondering why it's so difficult to build the A380s at this point. I mean, you've been doing it now for 6 or 7 years. And what does that say about the potential learning curve for the 350? That's a plane that's going to have to get it right away because you don't have a lot of time margin.
Sure. I think what Tim was referring to was the retrofit program, Andrea. It wasn't the forward fit. So the forward fit program is fine. The production of wings going through the plant today. The big issue was that we actually stopped, in fact really slowed down and stopped at one stage, the production. So you'd have to go back and look at the production charts for the early part of last year and you'll see a big dip. And then that's starting to come through now in terms of deliveries. Tim's talking about the retrofit program.
My understanding is you said that was delayed by the regular program.
No. What happened was that the retrofit program was delayed, in the case of Tim's aircraft, by a couple of weeks. It's not a big delay. But the reason for that is that if you look at the retrofit, the bill of material, it sounds a bit mundane, but even things like the fasteners, you have to use special size fasteners in that situation. And they have to be made in accordance to what's already on the wing. So when you do the actual mapping and inspection of the wing, you can have variations, because we use different size fasteners in different combinations, even in production. You can go up and down in sizes, grip length, etc. Even from wing to wing. That's not unusual with tolling stacker. So you have to survey each wing. That often means you then need special fasteners, and you've got to react to that. Now, we're putting in place a process to do that, but you can't just go out and order 100 sets of all the fasteners and have a standard production run. So it's really about getting the special parts in place.
Next question over there.
I'm from Wings Magazine, Thailand. With the introduction of A350, do you think it will be a product cannibalization to A330? Because according to our interview with Singapore Airlines or Thai Airways International, they say they have been using A330 for temporarily before receiving A350.
Yeah, I think the answer to your question is yes. Will the 350 cannibalize the 330 for sure? I think we would actually be, if we're honest, we'd say we're really pleasantly surprised how much the 330 has held up, because we thought the 350 would cannibalize the 330 much more aggressively. We had thought at one time that we might be down around 40 or 50 330s a year by this point in time. So to be up over 100, we're still really delighted with that. And as I said earlier, I think we always recognise that there will come a time when more 350s and 787s come into the market, that the 330 will be squeezed. We do, however, believe that there's still a lot of life left in the 330. That's why we're doing the 242-ton version. And we think it still makes a very good regional aircraft, particularly in markets like Asia. So the answer to your question is yes, it will cannibalise without doubt.
Next to FT.
Yes, Tom, just to follow up on that, really. Do you think in the wide-body twin market that you're going to need another new aircraft in addition to the 350 to compete properly with Boeing, given they have got 787 and planned 777 upgrade? In other words, 330 is aging.
I think today, I mean, as Fabrice touched on it, we've got a different situation because we've got the 380 and the 350, so we can be relatively relaxed. I think the Dash 1000, certainly from all the analysis I've seen, will be a very powerful airplane. I'm not sure, is your question at the top end of the 350 range, or do you think a gap at the bottom end of the range?
Well, some analysts would argue there's going to be a gap at the bottom end. But I'm interested in whether, overall you accept there's going to be...
If Boeing have got if you look at the measured backlog, they've got a clear market lead in wide-body twin. So if you're serious about closing that gap, do you think you're going to have to develop a new wide-body twin in addition to the 350 to get to market parity?
I think if you were to talk to the commercial guys, they would want to have every variation of aeroplane in 50-seat increments from 50 up to 1,000 if you gave them what they wanted. And so every day someone comes into my office and tells me that the aeroplanes are the wrong size and they should be this size or that size for this customer or the next customer. In the end, it also comes back to the business case. Can we make a decent business case out of it? So especially now we've got a more demanding set of shareholders probably. So we're in a situation where, for me, I think the portfolio we've got at the moment, as we stretch the capability of the 321 to its top limit, as we look at what we can still do with the performance of the 330, and then where we're positioned with the 350, 800 and 900 and 1000, and then feeding through onto the 380, I think the footprint's pretty good. And certainly in our discussion, I can't see that big of a gap that anyone could exploit. I think we've got a decent portfolio. Albeit, as I say, the commercial guys would always want every potential combination.
Last question of this session goes to Tim Robinson.
Right. Actually, it was question was already asked about sort of stretching the A380, so I'll use my supplemental. Well, what happened to the fat seat that was sort of revealed last year at last year's Innovation Days at the kind of extra wide seat for the extra wide passenger, a single aisle?
It's an option that customers could request if they wanted to. I mean, we've got the aisle width on the 320 to do that. There's not a lot of demand for it. I mean, I haven't seen much in the way of demand. It's not a big issue. But
we have tomorrow Chris Emerson here to answer this question.
Okay, then.
Do we have another question on Neo? Over there from our colleague from China.
Hi, I actually have a question in regard to the Airbus A320neo program. We know that in China there are a lot of high-altitude airports, and some airlines are actually already using the A320 still flying into those airports. With the new, because they get new engines, do you anticipate any performance change with the high-altitude airports?
No, it is one of our top program requirements was to have similar or better low-speed performance if you refer to takeoff and landing performance. And this has been achieved as any other target. So the performance will be either equal or you will even have a better performance for low speed, especially on high altitude airports, hot and high operations. Neo is doing equally good or even better than the Cirrus.
Then let's close this session. We have dinner ahead, which will be